We have our two types of circuit configurations set up here. We have series, we have parallel. Now, I've always found it really helpful, in order to visualize the difference between these, to actually set up a circuit and see how it changes between these two configurations. So let's go ahead and do that. I've got these same light bulbs that we were using previously. And so let's think about how we would connect these in series. We've already done this, so this should be familiar. If I wanted to connect these in series, I would need to connect these wires just one in a row, each one like that. And then my power supply, let's pull this over here, I'd connect one lead to one end and the other lead to the other end. So it would have this set up so that the current would flow through one and then through the other and then through the third. But what would this look like in parallel? Well, in parallel, these would all need to be lined up together so that all three of my input wires are connected, and so that all three of my output wires are connected. So if we connect it like that, besides it looking like a jumbled mess here, we can kind of see what's going on. We put all of them together. This looks like a complete mess. But that's just because of the way that I set it up. If I were to connect my power source to these three light bulbs in parallel, well, then all of my current is going to flow through all three light bulbs at the same time. So let's actually connect these into a breadboard so that we can see how our voltage and our current changes between the two configurations. So first off, let's set up a series circuit. All right, I've got a series circuit set up here. We can see, just like before, I've got my lead going into one, going through that light bulb, going into the other, and then going through the third one. So one at a time. So let's hook these up. I'm going to separate my wires here so I don't kill myself. Okay, let's turn it on. 0 volts. Current is ready to go. So we're turning up my voltage. As I turn up my voltage, I can start to see my lights coming on. And because I've got 3 in a row, I'm going to have to bring this up to above 7.5 to get a really significant current. And these, I know these can take at least 150 milliamps, so let's bring it up. So there we go. We've got a good brightness going here. And so we can see, based on my configuration, I've got current going in through my black lead, going through each of these, and coming out my red lead. Let's take this apart and set it up as a parallel circuit and see how that changes things with our values. Okay, so with this configuration, we can actually see this pretty well, how these are all going to come about. I've got one lead connected here and another lead connected here. So if I were to take this, if I were to put up voltage across this, well, then that voltage is going to be across this light bulb, it's going to be across this light bulb, and it's going to be across this light bulb. So all three of these light bulbs are going to see the exact same voltage. So by setting this up this way, we can really see that concept with our own eyes, instead of just looking at a drawing. So as I connect these, what would happen to the current at those voltages? What would happen if I turned this on and put it to the same voltage? Notice I'm turning it down now because I just remembered it was already up, and put it to that same 10 volts. Remember in the last video when we burned out one of these bulbs? What voltage did we burn it out at? Now I can't remember off the top of my head. I think it was 4.5, 5 volts. So if I put 10 right here, I'm going to have 10 volts across all three of these. Each one of these is going to see the same current as if I just connected one of them to 10 volts. If I just started this thing at 10 volts, all three of these would burn out. So we're starting at 0. Let's see how it changes as we turn it up. So I can see Remember, when I have one light bulb in here at 2.5 volts, I get a decent brightness out of it. Notice how much higher my current is. My current is at 440 milliamps. I have a lot more current because each of these is providing a path for that charge to flow through. So because there's 3 paths, there's going to be 3 times as much current. So if I turn this up a little more, there we go. We have a really good brightness here. So what would happen if I took one of these out? Well, we can just really quickly disconnect one. I just disconnected one wire, and I see my voltage stays the same. The brightness here stays the same. My current goes down. So with that in mind, do you think the lights in your house are set up in a series configuration or parallel configuration? If you turn one off, do the others stay as bright, or do they shut off immediately?